Okay, step one. You can even write this down if you want to. Step one. Choose a variable to eliminate. Choose two equations and one of the variables to eliminate. Okay, so I'm going to look at my x's. The LCM is 6. Remember when we used to write the LCMs out? You can still do that if it helps you. So you can choose which one to eliminate. LCM of the x's is 6. Y's is 2. And z's is 1. So which one would be easiest to eliminate? Z's, yeah. You don't have to do much multiplying, that's for sure. Okay, so choose your z's. So I decided I want to eliminate z's. So when I eliminate z's, choose two equations to start. So I'm going to choose equation 1 and 2. Those are really nice because these will eliminate and we don't have to multiply either equation by anything. So I'm going to choose equation 1 and 2. And add them to eliminate my z's. Two x minus x is just x. Negative y plus 2y is just y. My z's cancel, equals 5. Now, the next step, you need to make sure you know this. After you choose equations 1 and 2, there's still an equation in there that I have not used yet. I have not used equation 3. So I must use equation 3 when I do this again. But now I can choose either 1 or 2. It doesn't matter. But as long as I have 3, you can choose 2 and you're going to get the same answer. You can choose 1 and you're going to get the same answer. I like to look at equation 3 and think, okay, would it be easier to eliminate the z's with equation 2 or equation 1? 1. So I'm going to choose equation 1. And we're still eliminating z's. Now, you need to listen very carefully when I say this. You must eliminate the same variable both times. This is where most students make their mistake. I eliminated z's when I chose the first two equations. I must eliminate z's again. You cannot switch variables. You cannot eliminate z's in equation 1 and 2 and then go to equation 3 and 1 and eliminate y's. You cannot do that. That's where most students mess up. Okay? Yeah, for now. We're not quite completely done. Well, it's not. We're done for right now. Okay, for that one. All right, so I'm going to choose 3 and 1. I have 3x plus y plus z equals 16. And I have 2x minus y minus z equals 4. Do I have to multiply anything to get rid of the z's? No. They're already plus 1 minus 1. So I'm just going to add the equation. I'm going to have 5x. Ooh, this works out very nicely. Because we're going to be able to eliminate y's and z's. Okay? Equals 20.
And divide by 20.
That doesn't always happen. Sometimes you're left with x's and y's, then you have to use your two equations to solve for y. And then once you have y, you go back up. We'll do one like that. Okay? So this is nice. My y's were gone too. So can I figure out what x is?
Divide by 5.
Yeah, divide both sides by 5.
4.
So x is 4. Okay, now, if you know what x is, take your x and plug it in the next step up. So I'm going to have 4 plus y equals 5. Subtract 4 from both sides, and I get y equals 1. So now I have x, and I have y. How do I find z? Go all the way back up to the top and plug in your x, y, and z. I'm going to use another sheet of paper like this so that you guys can see. Doesn't matter which equation you choose. It doesn't matter. Pick one. I'll use the first one. So I have 2x, so 2 times 4 minus y minus z. Oh, what is y? I know what y is, don't I? Y is 1 minus z equals 4. So I have 2 times 4 is 8, minus 1 minus z equals 4. 8 minus 1 is 7, minus z equals 4. Subtract 7. I'm just playing algebra. So now you have x, and you have y, and you have z. That's your answer. Then your final answer I want written as a point. X is 4, y is 1, and z is 3. It's 4, 1, 3. So we would go out 4 over 1 and up 3. That's where they all intersect, those 3 lines. That is a lot, like I told you. It's a lot of work for one problem. It's not hard, but it's a lot of work. Bye.